I've got tons of side-by-sides to show you, and I have tons of bar graphs to show you, and the overall idea is going to be the 5070 Ti is about 11 or 12% faster than the 4070 Ti Super, which it's replacing at a similar but actually slightly lower MSRP. But as soon as we mention MSRP, we now need to have a massive caveat type discussion, which is, okay, I have the 5070 Ti Prime model from ASUS, and this is meant to be an MSRP product. And I have looked up the pricing at Micro Center 2 nights before launch, 1 night before this video shows up for you when the review embargo lifts, and it is listed at that price. I don't know how many what the supply will be though, how many will actually be available at that price, because every single other model I'm seeing listed here is $900 or more. Most of them more. Some of them $1,000 or even more, despite the fact that that's technically past the MSRP of a 5080. Not that you can really find 5080s at that pricing right now anyway. So in any kind of a value discussion here, it's gonna be hard to talk about because this is being listed at $750. So if we evaluate it based on that, we get one thing, and if we evaluate it based on what it might end up actually selling for once the initial supply on launch day runs out, would be another thing. The good news is, on my channel, I update my head-to-heads and GPU buying guides constantly, keeping track of current market pricing. So anyway, there's that. If you're frustrated with GPU pricing right now, you should check out Jawa.gg. This is a buy, sell, and upgrade market system between gamers, and you can find some amazing deals on this site, as well as find exactly what sort of pre-built system you are looking for, get the perfect match to a PC. You can even search by themes if you're looking for a certain aesthetic. And also, you can fund your upgrade by selling your old hardware. You can click the Get an Instant Offer button to sell your GPU or CPU to Jawa directly for an instant offer, which is super convenient. However, if you'd rather set your own price and list it yourself, you can become a seller on Jawa. It can even become a side business. It's pretty awesome. There's tons of positive reviews. There's a huge and very active Discord community to get that one-on-one feedback on your builds. And best of all, I can get you $10 off your first purchase using code OWEN10. And a huge thank you to Jawa for sponsoring this video and making the massive amount of side-by-side testing that I've done here possible. Now, let's also quickly mention that I am tracking things like temperatures and all of that. So if you're curious, how is the 5070 Ti Prime from ASUS doing? I will say that I think it keeps it cool. You can keep your eye on the temperatures throughout all the side-by-sides. Also, I like the look of this card. Looks pretty sleek compared to a lot of others, as well as it has the BIOS switch between the performance mode and quiet mode. I left it in performance mode for the purposes of testing and did not notice any excessive fan noise or anything like that throughout the video. Anyway, let's go ahead and get into the actual experience difference between the 4070 Ti Super, which is the most recent NVIDIA card in this price class that came out 1 year ago, versus the new 5070 Ti, which we hope to be available in this price class. Now, the thing is, if we're only getting about an 11% performance increase, which is what we're seeing here in 4K RT Overdrive mode with DLSS performance using the new transformer model in Cyberpunk 2077. The problem is that that's not really enough to make 4K path tracing suddenly doable on a 70 Ti class card here. The 4070 Ti Super hit 47 FPS at these settings, and the 5070 Ti only hits 52 FPS at these settings. So I wouldn't say that's a mind-blowingly different experience, nor would I consider this acceptable performance for a good 4K experience with path tracing. To be clear, many other 4K experiences are much easier to run, but if you're trying to do the full NVIDIA feature set, this isn't gonna manage it nicely at 4K, even with performance mode upscaling. Will the new frame generation solve all of your problems at 4K? I think the answer is no if we're talking path tracing mode. Because here, well, it's a 12% improvement over the 4070 Ti Super when they're like for like in ×2 frame gen mode, or even double the FPS, not performance, but FPS in ×4 versus ×2 mode, since ×2 mode is the best the 4070 Ti Super could do. Let's stop for a second and actually look carefully at what we're actually seeing here. So first of all, notice there's frame rate numbers, but there's also these latency numbers I'm getting right here. And that's important to note because while we're getting 161 FPS on average using the x4 frame gen mode on the 5070 Ti, it's coming in with around 50 milliseconds of PC latency. Notice that that's the same as the PC latency that we're hitting here on the 4070 Ti Super in its x2 frame gen mode. So despite the fact that we're basically doubling the frame rate, the game is not any more responsive. And both of these actually feel more like you're running at about 40 frames per second using, but with reflex enabled, if you're talking about what it actually feels like from a responsiveness standpoint. Also, 40 FPS is a bit low if we're talking about avoiding all image quality artifacts. It might look okay. People have different tolerance levels. So I'm not saying FrameGen's not useful, but I'm saying that the path tracing 4K performance that we got as a baseline was a bit low for my tastes. So I don't think that this is providing an excellent 4K path tracing experience here from a responsiveness or even necessarily an image quality standpoint, because the higher the base frame rate, the easier job it has for frame interpolation. But if you are targeting a 1440p display, you might be in better shape, although still don't be expecting to run path tracing at native 1440p resolution. If we try 1440p RT Overdrive in Cyberpunk, the 4070 Ti Super could only do 30 FPS, and the 5070 Ti can hit 35 FPS. That gives it a 17% advantage, which is one of the bigger leads we're going to see in today's video. But still, that's only 30 FPS versus 35. These aren't the frames that you're looking for on a $750 MSRP, but might end up costing $1,000 in the actual market GPU. But if you only kick on quality level upscaling, you get a massive performance boost. And the new transformer model looks quite good, especially with the new ray reconstruction. And now we can see the 5070 Ti is hitting 64 FPS. The 4070 Ti Super hitting 57. So actually a pretty decent experience here, although I think a lot of people would still be chasing an even higher than 60 FPS baseline if you're talking about extremely high-end PC gaming, which is where these are priced. But again, pretty decent experience now overall. The 5070 Ti about 12% faster. Now, if we use this kind of performance as a baseline for frame generation, we get a bit better experience than we did at 4K. Notice that if you're both in x2 mode, I'm only seeing a 7% advantage for the 5070 Ti versus the 4070 Ti Super. If we're in the x2 versus the x4 mode, so max you had available on either one, now the 5070 Ti has a 93% leader. In other words, almost double the frame rate, but again, similar responsiveness. Again, it'll feel like 50-ish FPS, but it will look like a much higher motion fluidity. I still feel like we're right on the borderline of the kind of baseline frame rates where I think for some people this is a good enough baseline frame rate for FrameGen to be a very good experience, and other people would be seeking an even higher baseline frame rate. Which is why I also took a look at using DLSS balanced mode, which again, with the new transformer model, I'm a lot more willing to push more aggressive DLSS settings than I used to be with the older CNN model. Using the balanced mode at 1440p output, we're now hitting 70 FPS on the 4070 Ti Super and 77 FPS on the 5070 Ti, giving us a 10% lead for the newer card. And that also increases our baseline frame rates noticeably to where now if we use frame generation, I think most people would consider this a good experience, although some people will be pickier than others. So here we're seeing that both in x2 mode, it's only a 7% lead for the 5070 Ti at 128 FPS versus 120. Again, the actual responsiveness will feel like about half of that, so around a 60 to 64 FPS. And in x4 mode versus x2 mode, so max versus max capable, we're at 228 versus 120, which is 90% more frames, but about the same responsiveness. So, you know, again, hard to represent that in terms of a percentage differential, because usually, again, with traditionally, more frames gets you more responsiveness. and motion fluidity, this gets you one but not the other. So anyway, still, I think this would be a good experience on like a 240 hertz 1440p display, something like that. This would be filling out that monitor's refresh rate pretty well. At 1080p, notice that neither card can actually even hit 60 FPS in a native 1080p path tracing. So this just shows how difficult path tracing is. 51 FPS versus 55 here. It's an 8% lead for the 5070 Ti. So honestly, even at 1080p, you'd probably be using DLSS if you wanted a good path tracing experience. If we go ahead and move on, though, not every ray tracing experience is as crazy demanding as path tracing mode is. In Indiana Jones, which is a game where you can't turn ray tracing off, you have to use it. The good news is that Supreme settings, if we don't turn on the full RT path tracing mode, runs great even at native 4K. We're talking 73 FPS and 83 respectively. 14% lead for the 5070 Ti, but I'm not sure it's like a mind-blowing advantage over the previous generation card, right? But it is better. If you turn on DLSS quality at 4K Supreme settings, which again is the highest non-path tracing settings in the game, we're getting 100 FPS versus 114, which is a nice 14% advantage. It's a little bit smoother. But again, not really a mind-blowing upgrade from what we had available last year. If we go to 1440p resolution, now no upscaling needed to hit nice high refresh rate experience, 115 FPS versus 127. That's a 10% advantage for the 5070 Ti. And if we go down to 1080p resolution, it's an 11% lead for the 5070 Ti at 157 FPS versus 142. So Indiana Jones and the Great Circle, if you just stick to the non-path tracing modes, is a really very performant ray tracing experience that looks quite good. If we jump into Silent Hill 2 to look at an Unreal Engine 5 ray tracing experience, this is one of the few games that allows hardware ray tracing to be turned on in the PC version. We get 4K epic settings at RT. I had to go down to DLSS performance mode to get what I think would be the kind of frame rates you'd be looking for here, which is 71 versus 79, 11% lead for the 5070 Ti. If you turn hardware ray tracing off but leave the epic settings otherwise maxed out, we're hitting 83 versus 95, so 14% advantage for the 5070 Ti. If we go to 1440p, you can run the epic settings with hardware ray tracing turned on at around 60 FPS. It's 59 on the 4070 Ti Super and 65 on the 5070 Ti, giving it a 10% lead for the newer card. And if you kick on DLSS quality, frame rates jump significantly to 83 and 91 respectively, 10% advantage for the 5070 Ti. At 1440p epic settings but no upscaling, so native resolution but also no hardware RT, it's 72 FPS versus 84, 17% lead for the 5070 Ti. At 1080p epic with hardware ray tracing turned on, it's 81 versus 89, 10% advantage for the 5070 Ti. If you want 1080p epic settings but no hardware ray tracing, it's 98 versus 113, a 15% advantage for the 5070 Ti. Another Unreal Engine 5 showcase, but this one does not feature hardware ray tracing, and high is the highest settings in the game. We're going to struggle to run a native 4K maxed out. It's 44 FPS versus 40, so 10% advantage for the 5070 Ti. But I think you'd probably end up kicking on DLSS. If we go to DLSS quality, we're now at 67 versus 73, 9% lead for the 5070 Ti. But again, are you noticing that, like, I don't think it's a mind-blowingly different experience compared to what we had available for the last year. If we go ahead and run at 1440p resolution, we're seeing 69, nice, versus 74, only a 7% lead for the 5070 Ti. Also, one thing I should mention in this game, there's an issue with the 50 series. These are running on the same driver. They're both using the review driver, but do you notice that there's more aliasing on the 5070 Ti? All of my 50 series cards, the 5090, 5080, and 5070 Ti, are showing a lot of aliasing in this game when you're running at the native resolution using TSR. It's cleared up when you're using DLSS, but it's not showing that issue on my 30 or 40 series cards I've tested at the same settings using the same driver. No, it's really noticeable here at 1080p. Look at the ground on the right-hand side of the screen and the brush and things like that. Really pixelated on the 50 series cards. So this seems to be some kind of issue going on with the 50 series cards. Anyway, but yeah, they're both running the same driver, to be clear. Anyway, at 1080p high, we're at 91 versus 97 FPS. And again, good experience on both. 7% faster on the 5070 Ti. Weird pixelation issues though. If we switch to God of War Ragnarok at 4K Ultra, we're seeing both GPUs doing well, 62 versus 73. It's a 17% advantage for the 5070 Ti. And if you want to fill out more of a high refresh rate 4K monitor, you could kick on DLSS quality, and now you're at 88 versus 100 FPS. So great experience on both, and it's a 14% advantage for the 5070 Ti. 1440p Ultra, I don't think you need any kind of upscaling or anything. You're at 96 versus 112. Great experience for a single player game, 17% lead for the 5070 Ti. If we go to 1080p Ultra, it's 118 FPS versus 137, 16% advantage for the 5070 Ti. If we go to Final Fantasy 16 at 4K Ultra, this is another game where you probably would want to use upscaling because we're only hitting 41 and 47 FPS respectively, 15% advantage for the 5070 Ti. If you kick on DLSS performance mode, you could go less aggressive, but if we use performance mode, it's 81 versus 93. So you'll feel more at home on a higher refresh rate display. Again, that's without any frame generation yet. 15% advantage for the 5070 Ti. At 1440p Ultra, 72 versus 80, pretty good experience here. You could still use upscaling if you'd like, or frame generation, but pretty good frame rates at the 1440p Ultra settings. At 1080p Ultra, we're at 98 versus 108, so I don't think you need to turn anything down or use upscaling, which I would hope is the case on a at 1080p on a $750 at least dollar graphics card. Horizon Forbidden West, at the maximum settings the game offers, which is called very high. The 4070 Ti Super is hitting 60 FPS in my run here, and the 5070 Ti is hitting 65, giving it an 8% advantage. If we kick on DLSS quality, you'll feel more smooth on a higher refresh rate display at 86 versus 97, 13% advantage for the 5070 Ti. And if we go to 1440p, very high settings, I don't think you'll need any DLSS or anything in a single player title at 104 FPS versus 112, giving an 8% advantage to the 5070 Ti. At 1080p, we're hitting 133 versus 146, giving a 10% advantage for the 5070 Ti. If we go to Ghost of Tsushima, 4K very high settings, which again are the highest settings the game has to offer, we're hitting 65 versus 60, which is an 8% advantage for the 5070 Ti. It's a good experience, but I think using DLSS, at least at the quality setting, would be a better experience because now we're up to 94 and 103 FPS respectively, 10% advantage for the 5070 Ti, and it'll feel good on the higher refresh rate display. At 1440p, we can do max settings at 104 versus 112, which is an 8% lead for the 5070 Ti. And at 1080p resolution, we can do 151 FPS versus 138, 9% lead for the 5070 Ti. If we look at a multiplayer game like Call of Duty Black Ops 6 at the basic settings, so in a lot of competitive titles, people will turn down graphic settings to get a competitive edge both in terms of frame rate as well as decluttering the environment, visibility lines, getting unnecessary vegetation out of their way, things like that. So that's why I'm using the basic settings here. We're seeing a 6% lead for the 5070 Ti at 133 FPS versus 126. It would probably make sense to also use upscaling to chase an even higher refresh rate for a competitive title if your monitor refresh rate goes higher. At 1440p basic settings, no upscaling, we're seeing a 5% lead for the 5070 Ti at 224 versus 214. And at 1080p resolution, it's 292 versus 285, only a 3% advantage for the 5070 Ti. But it's possible starting to see some other system limitations. Notice that neither GPU is pegged at 100% utilization here. And I'm hearing stomps, so my kids are getting home if you hear stomping on the roof above us. Anyway, that's also all the tests I ran. So let's do an overall look at this. So if you look at all of the tests I ran, this is not showing frame rate. This is showing the percentage differential for the 5070 Ti versus the 4070 Ti Super. And game by game, you can see the differences. Basically, it ranges from 5% faster to 17% faster, but if we do this as the geo mean of all results, the 5070 Ti is 11% faster. But some of these, especially at 1080p resolution, can be more system limited. So the true difference between the two GPUs is probably better represented by filtering just the 4K results. in which case we're seeing the differences range from 6 to 17% faster, and the geo mean come out as 12%. If you're curious, what if we just limited it to ray tracing? In that case, I am seeing an 11% faster result. In general, we're seeing 11 to 12% faster. I think I'll go with the 12% for my analysis. And so what does this mean in terms of value? Well, again, the card I am doing here is meant to be $750. So we can start with that, but we're certainly not going to leave it at that. So at $750, with the previous generation MSRP supposed to be $800, we could do this calculation. Our price ratio is we are at 93.75% of the MSRP of the previous generation, but our performance is 1.12 times the performance. So if we divide these, we get a performance per dollar improvement generationally when comparing the 5070 Ti to the 4070 Ti Super, which came out 1 year ago. So if everything was actually available at MSRP, that would mean this is about a 19.5, or let's just call it 20% performance per dollar improvement. So it's about a 12% performance improvement and a 20% performance per dollar improvement if we take into account the $50 reduction to the MSRP. Now, that in and of itself isn't particularly exciting, but hey, it does mean it is now offering better value at this price tier than we used to have available a year ago. And if we went back to the 4070 Ti non-Super, we'd see an even larger jump, and I will have a direct head-to-head video coming out on the channel with that comparison. But I think, again, the elephant in the room here is that there's only one model here. It is the one I'm reviewing, ASUS Prime, listed at $750 at Micro Center. The rest I'm seeing here are $900 and up. So that would change these calculations a bit. So if we said that our price was actually $900, and then we took that price ratio and put it in the denominator of this ratio, that would actually show a regression, or really basically a tie. It would basically mean there has been no improvement in performance per dollar when compared to the 4070 Ti Super. And if you look at the $1,000 models, if that ends up being what these cost, then things get worse, right? So that would be like a 25% MSRP increase. And so if you factor that into here, then we're actually offering only 90% of the performance per dollar that we did last generation, right? So should you rush out and buy a 5070 Ti if you can find one at launch? Well, if you can find one at the $750 MSRP, it is the best performance that has been available at that price from NVIDIA by about 20%-ish performance per dollar, and it's about 12% more performance. If it's anything above that, it's at best stagnation in performance per dollar if you're seeing these available for about $900. And if they're above $900, it's now a regression in performance per dollar compared to the previous generation that was available a year ago. And I want to be clear that 4070 Ti Supers were available at or below MSRP for a long time. They're not anymore because they've gone out of production to make room for the 50 series. But if I track a MSRP model, like here's the MSI Ventus 2XOC, I track its pricing at a variety of retailers, you can see that this launched at MSRP. It was available at that price and then was actually discounted $10, even down to $770. It looks like the lowest pricing I'm seeing here. So anyway, 4070 Ti Supers have absolutely been available at or even below their $800 MSRP on a regular basis for the last year. Which means, again, if the pricing you're finding on these is anything above $750 to $800, it is not a generational improvement. The only generational improvement is really then in frame generation. And like I said, that is a nice to have on a high refresh rate display, but it's not a true performance increase. It's not going to make a 40 FPS experience suddenly great. It might fill out your high refresh rate display if you could already achieve a decent base frame rate. Now, what about the 5070 Ti itself? Just like, is it good enough for your use case? Well, that's where I wanted to say that it is a very powerful graphics card. The only thing that I don't think it can do well is 4K path tracing. I think it can do 4K gaming well, but not 4K path tracing well. I just thought even with performance mode upscaling, we're still falling short of 60 FPS, which means it's not going to be a great baseline from which to use frame generation, and that's in the titles we have now. It's possible that future titles could be even more demanding. Whereas I do think it's a good 1440p path tracing GPU, because with quality level upscaling, you can get around 60 FPS, and with balanced level upscaling, we saw that we were getting an even higher base frame rate. With the new transformer model, it can look okay. With frame gen, it can fill out a high refresh rate display. So I will say that I do think just from is it a good card, let's ignore value. I think it's a do everything 1440p card, and it's a do everything except for path tracing 4K card. And yes, it's more than enough for 1080p, but honestly, even 1080p path tracing, if you're trying to do it natively, is still kind of ridiculous. Anyway, so that's where I'm at with that. It is a powerful card. And especially if you're on a 1440p display, I think you'd be very happy with its overall performance and feature set. It's just the pricing could be an issue. That's where I'm at with that. If you guys want a whole bunch of other head-to-heads with this 5070 Ti, they are absolutely incoming. I'll have one against the 4070 Ti. I'll have one against the 5080. I'll also get it head-to-head against any relevant AMD competition in the near future, including once we get the 9070 and the 9070 XT. Anyway, just stay tuned to the channel for detailed head-to-heads and these big bar graphs and value and all that. And also, like I said, I do monitor market pricing and do monthly buying guides and things like that based on real-world pricing data and updated head-to-head comparison videos. So stay tuned to the channel if you're interested in all of that. And again, if you want to avoid the crazy new market pricing, check out Jawa.gg and get $10 off your first purchase using code 10 in the pinned comment and or video description. And again, you can sell your hardware to fund your upgrade. Because again, one of the biggest advantages to having hardware, and if GPU prices go through the roof, is that does also increase the value of selling yours. You could sell instantly to Jawa for convenience. You could list it yourself. All that's available. Anyway, thanks again to them for sponsoring today's video, and I hope all of you have an excellent day.